Hello everyone. This is tutorial week 11. In this tutorial, we will start from Fubini's theorem and then we will do some examples of polar coordinates, pair, uh, some questions on applications of double integrals. So let's start from Fubini's theorem. And the first question is evaluate the double integral y e to the power minus xy dA in the region R, where R is the region from 0 to 2 times 0 to 3. Okay, I can write this integral in two ways. The first is if I uh, compute the integral with respect to y first and then with respect to x, and the other is if I compute the integral with respect to x first and then with respect to y. In the left case, we are integrating with respect to y first, so I need to write the limits of y first as well. And then with respect to x, so the limits of x will be outside. Okay, on the right side, we are integrating with respect to x first, so the limits will be from 0 to 2. And then with respect to y, the limits will be from 0 to 3, right? So looking at at both the integrals, the left integral we are integrating with respect to y first. So we have two functions of y. One is y itself, and the other is e to the power minus xy. So we need integration by parts over here, which is slightly complex. And on the right side, uh, we are integrating with respect to x first, and e to the power minus xy is the only function with respect to x. So we can just easily integrate this. Okay, so we'll skip this one and compute this integral, right? Uh, okay, so I can write the integral is integral from 0 to 3 of, I can take y outside because it's not dependent on x. Okay, I can write this integral is the integral from 0 to 3 y, and e to the power minus xy integral will be e to the power minus xy divided by the derivative of this function with respect to x. Minus xy का derivative with respect to x is minus y. So evaluating this integral at 2 and 0 dy, I can just cancel this y and this y and take minus outside. So integral will become e to the power minus xy, and the limits are from 0 to 2 dy. Okay, so the integral becomes negative times. If I plug in x is equal to 2, the integral becomes e to the power minus 2y. And if I plug in x is equal to 0, the integral becomes 0. Okay, next, e to the power 0 is 1. So e to the power minus 2y minus 1 dy. Taking negative inside the integral, I can just write this as 1 minus e to the power minus 2y dy, and splitting the integral, I get integral from 0 to 3 of 1 dy minus integral from 0 to 3 of e to the power minus 2y of dy. Okay, integral of 1 with respect to y is y, and the limits will be from 0 to 3 minus integral of minus 2y with respect to y is e to the power minus 2y divided by the derivative of this function with respect to y, which is minus 2, and I need to evaluate this at 3 and 0. Okay, uh, in the first one, y को evaluate करना है at 0 and 3, so 3 minus 0 minus, if I plug in y is equal to 0, I get e to the power, if I plug in y is equal to 3 first, so I get e to the power minus 6 divided by minus 2, minus if I plug in y is equal to 0, I get e to the power 0 divided by minus 2. So I'm left with 3 minus this negative and this negative makes it a positive. So I get positive e to the power minus 6 over 2. This negative with this negative makes it a positive, and again multiplied with this negative makes it a negative, minus 1 over 2. 3 minus 1 over 2 is 5 over 2 plus e to the power minus 6 divided by 2. You get 5 plus e to the power negative 6 divided by 2, which is the answer of this integral. Okay, the other example is uh, evaluating the integral y divided by x power 5 plus 1 dA over the region D, where D is the region xy, where x goes from 0 to 1 and y goes from 0 to x square. So if I draw this region over which I am evaluating this integral, it will somewhat look like this. This is x-axis, y-axis, and if I draw y is equal to x square, okay, so x is going from 0 to 1, so from 0 till 1, over here the value of the function will be 1, so the point will be 1 comma 1. Over here the y coordinate is 1 as well, right? So the y value goes from y is equal to 0, which is this one, till y is equal to x square, and the x value goes from 0 to 1, right? So we are evaluating this integral at this region, right? So this is type 1 region because हम पहले y की limits पहले with respect to y evaluate कर रहे हैं और फिर with respect to x. So my integral will be x की limit outside and y की limits will be y is equal to 0 and y is equal to x square. The integral will be y over x power 5 plus 1 with respect to y and with respect to x. And I can write this integral is, if I evaluate this integral with respect to x and then with respect to y, and if I evaluate this integral with respect to y बाद में, तो y की values are going from 0 to 1, so y is equal to 0 till y is equal to 1, and x की values are going from y is equal to x square, so x is equal to under the root 4. So x is equal to under the root y, sorry, under the root y till from here till here. So this line is y is equal to x is equal to 1. So the x value will be, from x limits will be x is equal to under root 2 under the root y till x is equal to 1. So looking at both the integrals, if I see इस case में I need to evaluate with respect to x first. So x का जो function है denominator में x power 5 plus 1, and the integral of which is 5x power 4, and जो कि पूरा इंटीग्रल में हमारे पास मौजूद नहीं है, और चूंकि इसका डेरिवेटिव इसके साथ मल्टीप्लाई नहीं हो रहा, तो आई can't just compute this integral ऐसे. I need numerical methods to evaluate this integral, which is very complex. And if I look at this integral, इस case में I need to evaluate this integral with respect to y first. So with respect to y हमारे पास function है सिर्फ y, तो उसका इंटीग्रल लेना बहुत ईजी है. So I can write this is I will evaluate this integral, right? Not this one, because this is very complex. I can take the x power 5 plus 1 outside because it's independent of y. and y is equal to 0, y is equal to x square of y dy dx. Integral of y with respect to y is y square over 2, and the limits are x square and 0. So if I plug in y is equal to x square, I get x power 4 over 2. And if I plug in y is equal to 0, I get 0 minus 2. Okay, I can ignore the 0 term, so the integral will become uh, x power 4 divided by 2 into x power 5 plus 1 with respect to x. So now my integral is very simple because x power 5 plus 1 का derivative 5x power 4 जो कि numerator में present है, and to make it 5x power 4 I multiply it 5 and divide 5. Okay, so now taking 2 outside, I get 1 over 10. The integral from 0 to 1, 5x power 4 divided by x power 5 plus 1 with respect to x. So now this is the function in the denominator and the derivative of which is being multiplied with it, right? So I can just write this as ln of absolute of x power 5 plus 1, and the limits are from 0 to 1. Okay, if I plug in x is equal to 1, so I get 1 power 5, which is 1. 1 plus 1 is 2. And if I plug in x is equal to 0, so I get 1 over 10 ln of 0. So ln of 1, sorry, ln of 1, and ln of 1 is 0, so the answer will be ln of absolute 2 or ln of just 2 divided by 10. Okay, and the next question is evaluating the double integral. The outer integral is from y is equal to 0 till y is equal to 8, and the inner one is x is equal to cube root of y, x is equal to 2 of e to the power x power 4 dx dy. Okay, if I just draw the region and on which we are evaluating this integral, so the integral will, the region will be somewhat like this. The y values are from 0 till 8. So the value corresponding to this 8 will be 2. Okay. So the outer limits are from y is equal to 0 till y is equal to 8, which are going from this all the way till this. And the x value goes from x is equal to cube root of y, which is again y is equal to x cube, and till x is equal to 2. X is equal to 2 is this line. So the region on which we are evaluating this integral is this one, right? I can just change the order of integration. Just I can write this integral is e to the power x power 4 dy dx. x की लिमिट्स सबसे बाहर हैं, तो x goes from 0 till 2. I can write this is x is equal to 2. Oh, x is equal to 0 till x is equal to 2, and my y value goes from y is equal to 0 till y is equal to x cube. So y is equal to 0 till y is equal to x cube, right? So I need to evaluate ओनली वन इंटीग्रल, दोनों में से जो भी इजी हो। सो इफ आई लुक एट द लेफ्ट साइड, ये वाला जो इंटीग्रल है, इस केस में आई नीड टू एवेलुएट विद रिस्पेक्ट टू एक्स फर्स्ट, एंड विद रिस्पेक्ट टू एक्स अगर मैं इसको एवेलुएट करना चाहूँ, ई टू द पावर एक्स पावर 4 है, एंड एक्स पावर 4 का इंटीग्रल, एक्स पावर 4 का डेरिवेटिव इसके साथ मल्टीप्लाई नहीं हो रहा है इधर कहीं। तो आई कैन जस्ट कंप्यूट दिस इंटीग्रल ऐसे ही। अगेन न्यूमेरिकल मेथड्स चाहिए इसके लिए विच आर वेरी कॉम्प्लेक्स, एंड लुकिंग एट दिस इंटीग्रल आई नीड टू इवेलुएट विद रिस्पेक्ट टू y फर्स्ट, एंड y का फंक्शन चूंकि नहीं है तो y इज इक्वल टू 1 ही हम एज्यूम करेंगे, एंड विच इज़ वेरी सिंपल टू इंटीग्रेट। So I'll just integrate this integral, right? And I can write this integral is x is equal to 0 till x is equal to 2. And I can just take the function of x outside because uh, y पे dependent नहीं है. Y is equal to 0 till y is equal to x cube of 1 dy dx. And integrating 1 with respect to y, you get y. Evaluating at limits from 0 to x cube dx. Okay, so plug in y is equal to x cube and y is equal to 0. You get x cube and 0, which is integral from 0 to 2 of e to the power x power 4 x cube dx. Right now, ये जो फंक्शन है e to the power x power 4 and x power 4 का derivative is 4x cube, which is being multiplied with it. So to make the perfect जो इसका derivative है, I multiply 4 with it and divide 4 with it. Okay, the integral becomes from 0 to 2 and 4x cube e to the power x power 4 dx. Now I can just write it as e to the power x4 because इसका डेरिवेटिव इसके साथ ही मल्टीप्लाई हो रहा है, and I need to evaluate this at limits 0 till 2. 1 over 4 e to the power, if I plug in x is equal to 2, so 2 power 4 is 16, and if I plug in x is equal to 0, 0 power 4 is 0, and e power 0 is 1. I get e to the power 16 minus 1 divided by 4. Okay, fourth question is evaluate the double integral, evaluate the triple integral of z dv over the region E, where E is tetrahedron bounded by 4 planes, x is equal to 0, y is equal to 0, z is equal to 0, and x plus y plus z is equal to 1. Okay, so if I want to draw this region on which I'm evaluating this integral in 3 dimensions, I'll have 8 octants, x, this is y, this is z. So I can just tweak this as z is equal to 1 minus x minus y. So at x is and y both equal to 0, my z value is 1. And again, if y is equal to 0, y axis और x axis के साथ भी 1 1 पे intersect करेगा. Okay, so if I draw this, this will be a triangular type region जो कि first octant में lie कर रहा है, right? So first octant में ही हम इस integral को evaluate कर रहे हैं, this triangle type of की जो region है, right? So basically हम ये 3D में ही हम इसको evaluate कर रहे हैं, right? सो इफ आई जस्ट सी, तो z की जो वैल्यूज हैं वो जा रही हैं 0 से -1 -x -y, because here, okay, over here z is equal to 0, and over here या इधर हम कहीं भी जाएं तो z is equal to 1 -x -y जो प्लान है उधर तक हमने इस इंटीग्रल को इवेलुएट करना है, राइट। एंड अगर हम इसको z is equal to 0 प्लेन पे इंटरसेक्ट करें जस्ट y और x की लिमिट्स निकालने के लिए, तो ये जो हमारा फंक्शन है, ये जो हमारा रीजन है, ये इस तरह का दिखेगा। अगर हम इसको z इज इक्वल टू 0 पे प्रोजेक्ट करें तो एक ट्रायंगल टाइप की बनेगी, जिसमें जो हमारे ये वाली जो लाइन है y इज इक्वल टू 1 - x है, और हम इस रीजन पे इंटीग्रल फाइंड करना चाह रहे हैं। तो y की जो लिमिट्स हैं वो जा रही हैं 0 से 1 - x तक, एंड x की जो लिमिट्स हैं, बिकॉज 0 से 1 तक जा रही हैं मैक्सिमम, तो x की जो लिमिट्स हैं वो 0 से 1 तक होंगी। Now I can write this triple integral is x is equal to 0 till x is equal to 1, and y is equal to 0 till y is equal to 1 minus x, and z is equal to 0 and z is equal to 1 minus x minus y of c dz dy dx, right? Okay, so evaluating with respect to z first, I get z square over 2, because z का integral is z square over 2, and the limits would be from 0 to 1 minus x minus y dy dx. So the integral becomes from 0 to 1, from 0 to 1 minus x, and if I plug in z is equal to 1 minus x minus y, so I get this whole square divided by 2 minus z की जगह अगर 0 plug in करता हूँ तो I get 0. I can just skip that dy dx, right? Now I need to evaluate this integral with respect to y. So this is a function of y, and the derivative of which is -1. So -1, I can multiply -1 with it, and -2 divide, because and taking -2 outside, I get 1 over -2 times into integral from 0 to 1, from 0 to 1 minus x, and -1 minus x minus y whole square dy dx, -1 by 2 integral from 0 to 1, and integral of this function with respect to y is, इसकी हम एक पावर में इंक्रीमेंट कर देंगे, तो the integral will be 1 minus x minus y whole to the power 2 plus 1, which is 3, and we'll divide it with 3 as well. So our integral will be 3 को हम outside ले जाएं, and evaluating this at the limits as well, 1 minus x 0. Okay, so I can take 3 outside. The integral will be -1 over 6 into x is equal to 0 till x is equal to 1. If I plug in y is equal to 1 minus x, so 1 minus x minus 1 by x, and minus, if I plug in y is equal to 0, 1 minus x minus 0, and cube as well dx. I can clearly see that this goes to 0, because 1 minus x minus 1 by 1 minus x is equal to 0. So the integral will be 1 minus x, integral from 0 to 1 of -1 minus x 3 and dx. Okay, so again, 1 minus x is a function of x. then derivative of which is -1, which is being multiplied with it outside. So I can just write this is my 1 minus x whole to the power 4 divided by 4, and evaluating this, it limits 1 and 0. So I get -1 by 6, and if I plug in x is equal to 1, I get 1 minus 1 divided by 4, minus if I plug in x is equal to 0, 1 minus 0 divided by 4. So this will be 0, and the other term will be with a negative sign, and negative makes it a positive. 1 over 6 into 1 over 4 is 1 over 24. That's it for this part.